Hi, this is Anisha Waghela. This is the video for the personal project of CMPE281. The project is on NoSQL databases. In week 1, I researched on the NoSQL database to be used in the project. For NoSQL database, we have a CAP principle. It stands for consistency, availability, and partition resistance. For the SQL databases, there are ACID properties, but in NoSQL databases, we can't guarantee that. So we have CAP principle, and we guarantee only two things at a time, either CA or AP or CP. And then I did research for the MongoDB that I can use in my project. MongoDB is a document-oriented NoSQL database and a cross-platform that provides high performance, high availability, and easy scalability. It uniquely allows users to mix and match multiple storage engines within a single deployment. It has various advantages like it stores data in flexible JSON-like documents, meaning fields can vary from document to document and data structure can be changed over time. Document model maps to objects in your application code, making data easy to work with. So this was the research done in week 1. In week 2, I researched on how to deploy MongoDB database to AWS. So MongoDB can be deployed on the flexible AWS platform and can set up a fully customizable MongoDB cluster on demand. It is scalable on-demand infrastructure on AWS, provides a cost-effective solution for handling large-scale compute and storage requirements. For deployment of MongoDB cluster on AWS, we need to follow the steps. Launch the AWS Cloud Formation template into the AWS account, specify parameter values, and create the stack. So these are the steps that I found when I researched for the same. In week 3, I created the EC2 instances with MongoDB and then formed a cluster. For creation of EC2 on AWS, we need to follow the steps. We need to create an EC2 instance with the following configuration, like choose an Amazon machine image. Then choose an instance type, select a VPC with private and public subnet, select public subnet for the VPC selected in the network. Then need to open the ports 22 for SSH and 27017 for MongoDB and configure the security group. Give the name as master node for this instance, like the first node that we are creating is the master node, and then create a AMI image for the instance created. But before that, we need to install MongoDB into that EC2. So connect to the EC2 instance that has been created and by doing the SSH command. Then install MongoDB on the EC2 instance using the following command. So these are the steps for installing MongoDB. Then run the command on the terminal to start the MongoDB. Use this command to start the MongoDB terminal. Then run Mongo to check that it is installed properly or not. Then after creating the instance, we will create AMI image of this instance, and then we'll replicate this to 4 other instances. Like, as we need a cluster of nodes, so we have created one EC2 instance which has MongoDB installed in it, and now we'll create the AMI image, and out of this AMI image we'll create another 4 instances. So one would be the master node and 3 nodes for the slave, like the slave node 1, slave node 2, slave node 3, and 1 arbiter. So in my AWS account we can see that there are 3 slave nodes, 1 master node, and 1 arbiter. So in slave node we can see the inbound rules, which shows that port 27017 and port 22 are open, and we have security groups. So now we have 5 nodes ready for our cluster formation. So for forming the cluster, we need to do this configuration. So we'll connect to the master node using the SSH command. Then we'll connect to MongoDB in that master node, and we'll create a user using the following command, and we'll run the below commands to create a shared key file to authenticate the connection between nodes on one of the nodes. Then we need to send the key file from the local to the master node. So it can be done using this command. Copy the internal key file in all other 4 nodes using the following command. Then run this command on AWS node where the MongoDB internal .key has been copied, and do the following changes to the file. Then terminate any process running on port 27017 using the following command so that we can run our service on that port. Start MongoDB on all the nodes by binding the IP, and commands to run on the master node to initiate the replica set and add nodes is this. So we need to do rs.initiate, rs.add, and rs.add_arbiter. So we are adding the slave IP, and we are adding the arbiter. And to connect on the slave node, to run on a slave node to connect to master node, we need to run this command rs.slave. Okay, and we need to do this use database name to use that DB. So after doing the following configuration, when we do rs.status, we can see that there is one primary node, secondary node, secondary, and one arbiter. So there is one primary, 3 secondary, and 1 arbiter node. So now we have a cluster of nodes that has been formed. Now we can do the testing, which is the purpose of this project. So for testing, I have configured. Just a second, I need to open my terminal. So these are the 5 terminals. This is my primary, this is the secondary, these 3 are secondary, and this is the arbiter node. So first of all, we'll check for the replication test. We'll try to insert one document in our Gumball collection, which is ID2. And so we will try to see that we are able to find that document in our secondary nodes. So we'll find so we can see that this ID that has been created here, ID2, the document that has been created in the primary node, we are able to view it in the secondary node. We'll try to find it in other secondary nodes also. We can even see here. We'll check in the 3rd secondary node too. So we can see that the document that has been created in primary node has been replicated in all the 3 secondary nodes. Now, so this was the first test of replication of the data that inserted document in the collection from the primary node, and when we try to find that document from any other connected nodes of the cluster, we will find it. Now the second test is a network partition test of 1 secondary from the primary. So we'll stop the connection of one of our secondary nodes from the primary node. So we'll do that using the command. We'll exit from this, and we'll drop the connection of this EC2 user, that means this secondary node, from our primary. So now we are disconnecting this primary node having IP 10.0.0.105 from our primary node, which is IP 10.0.0.239. So we'll do that using this command. It should be add. Now we'll start our Mongo. And we'll try to find this. Oh, we need to do rs.sleeve. Okay. And we'll use gumball collection. Now we'll try to find 2. So we are able to find, even though we don't have connection with the primary node, we are still able to find this because it was inserted before. Now when we try to insert a new entry in our primary node, let's say we insert a document with ID 3 in our primary node. Now when we try to find that document, we would be able to find that 2. This is because the connection of the secondary has been disconnected from the primary, but this is connected to the other secondary nodes. So it tries to bring that data while talking to the other secondary nodes, and despite of its connection being down with the primary node. So this was the second test, which was testing of network partition of one secondary from the primary. So we isolated one secondary node from the primary node using this command, and we inserted a document in the collection from the primary node. Now when we tried to find the newly inserted data from the isolated node, we are able to find it out. This is because the isolated secondary node is disconnected from the primary node but is connected to the other secondary nodes. So it reads the data from other secondary nodes and gives the output. Now for the third test, we'll do network partition of one secondary from all the other nodes, including other secondary nodes as well as the primary node. So for this, we'll disconnect this node from the other secondary nodes too. It is disconnected from the primary, and now we'll disconnect it from the other secondary node. This secondary node has IP 10.0.0.74, so we'll disconnect it from this, and we'll also disconnect it from this, which is 10.0.0.209. 209. We can even check its health. We'll start the Mongo, and we can see the status. So we see that this secondary has health 0 with the node having IP of 74. It has health 0 even with 209, and it has health 0 with 239. And this is for itself. It has health 1 off with itself. So we disconnected it from every other node of the cluster. And now when we try to find out, so we'll do rs.sleeve. Okay, then we'll use the gumball collection. Now when we try to find out this, we would be able to find it. This is because this is something that it already has. Now when we try to insert a new ID in the primary node, and when we try to find that new document, we won't be able to find. But when we try to find it from the other nodes, other secondary nodes which are connected to the primary, we can see that it gives out the document. So we are able to see that the document with ID 4, we can see it in the secondary node which is connected to primary, but we are not able to see it in this secondary node which is not connected to the primary or any other secondary node. Now we'll try to update a document which we can see here. A document with ID 3, we'll give it a new property called name and we'll update it. Now when we do db.find, db.gumball.find, in the primary node we see the updated value. Now when we try to find out that document in the secondary node which is not connected to any node, we'll see that we are not able to see the updated value. We are seeing the stale data. But when we try to access that document, when we try to find that document in another secondary node which is connected to the primary node, then we are able to see the updated value. So this is a property which shows that we are able to read the stale data from the node which is not connected to any other node. So this ensures availability of the data from the secondary node. So this was the third test where we isolated one secondary node from the primary as well as the other secondary nodes, and we inserted a document in the collection in the primary node. And now when we try to find the newly inserted document from the isolated node, we are not able to find that document. This is because the isolated node is disconnected from all the other nodes, so it won't be able to talk to any other node and bring that data. However, we are able to read the old data that has been inserted or updated before the secondary node was isolated. So yeah, this was the tests that has been performed to check the NoSQL database properties. Thank you. Hope you like it. Bye bye.